Hello and welcome to first lecture in chapter 19 on our comprehensive course on AI, ML and DS. Now, the name of the chapter is Introduction to Basic Statistics. You may find that why suddenly statistics? Actually, we were doing this part of data science life cycle in our previous 4 or 5 chapters. So now we slowly want to go here, model creation. And the feature engineering also, its advanced the examples will come with model creation only. But as soon as a model is created, next step is immediately model validation, where we use some statistical tests to decide if our model is matching our goals or not. Now, goals means what? For example, we can say that models are having a certain F1 score or a certain maybe this a certain precision, recall, or accuracy. Various metrics are there. Now, you have decided at the beginning of the whole data science life cycle only by consulting with the stakeholders that what will be the metrics that we want to consider. So here we want to consider suppose F1 score. So whether that F1 score is sufficient or not, that you have to decide by statistical parameters. In fact, most of the tests will also means most of the model creation processes, they will also give a huge output in which there will be several statistical terms. For example, if I show you one such output, then not in this chapter, but somewhere here, I think. Yeah, this kind of output you will see. Now you can see here that R squared and adjusted R squared and F statistic and probability, a likelihood, AIC and BIC. So that means once we build the model, immediately this next process would start. This next process of evaluating the model will start. And at that time, you have to have the knowledge of statistics. So I cannot teach you statistics at that time. I have to teach statistics before we start building the model. Okay, that is one reason. Another reason is that most important problem with data science is to design hypothesis. For example, if some client has approached, we have been taking this example right from right in many chapters. A client has approached you and asked you that I am spending my marketing money in 4 marketing channels: social media, newspaper, TV, and radio, and these are my marketing expenses. And I want to spend the total amount which I want to spend on marketing. I want to keep same, but I want to reshuffle it slightly so that maybe newspaper marketing budget I want to reduce by say $2 million, and I want to increase my social media marketing budget by $2 million, keeping the total constant. Now, is that a prudent strategy? So first you have to design a hypothesis that sales and profit both they are a function of these individual marketing budgets, and then you have to test that hypothesis. But how to test hypothesis? Have we learned so far in all these previous 18 chapters? No. While every data science project begins with designing a hypothesis and then testing it, and if you find that sales or profit are affected by marketing budgets, then you will proceed further and build the model. Okay, so it may be that sales and profit are not at all affected by marketing budget, or it may be that they are affected by total marketing budget, but out of that one component is completely useless. So that means that they are dependent on social media marketing, TV marketing, and radio marketing, but maybe they are not dependent on newspaper marketing. So first of all, before jumping on the data and cleaning the data and creating the model, you have to first check its hypothesis. That the client says he is spending on 4 channels, then I will first check that whether the sales and profit are function of social media marketing, yes or no. Whether the sales and profit are function of radio marketing, yes or no. Whether the sales and profit are function of TV marketing, yes or no. And whether they are function of newspaper marketing, yes or no. Once that much is decided, thereafter you have to start building all these things: model creation, training. And so hypothesis testing is also part of statistics, designing hypothesis and testing hypothesis. Okay, that is also part of statistics. So before the model creation also you need statistics, and after the model creation for evaluating your model, because as I said, if you get this kind of output, now what sense does it make? What is this Durbin-Watson, and what is this Jarque-Bera, and what is this omnibus and all that, kurtosis and all that. So statistics is, you can say, the heart of the real or pure data science process. Okay, so we have to do that, and therefore we have kept 19th chapter, Introduction to Basic Statistics. 20th chapter, its name is Practical Statistical Analysis in Python, and then this. So the next chapter is Advanced Statistical Analysis, and still next chapter, there we will start data pre-processing for machine learning. That is actually this kind of portion, feature engineering. And so that means once these 3 chapters are done, 19th Introduction, 20th Practical Statistics, Advanced Statistics, these 3 chapters and these 4 chapters, then this model creation and everything will start. Okay, so now let us continue with our 19th chapter. Now in 19th chapter, there are three portions. Statistic is basically divided into two parts: descriptive statistics and inferential statistics. Okay, so here we will first learn about descriptive statistics. Now this portion will almost, not almost, but exactly appear a revision, because I have already included that in this chapter, that is NumPy related chapter it was, and introduction to basic statistical methods in NumPy. So while learning, it was chapter number 5 much earlier, but while learning about applications of NumPy, I explained each and everything which was required for basic statistics. You can see that it was a very lengthy discussion, and if you see the lectures also, then there were several lectures to cover this portion, right? So this portion, basic statistics, will appear almost like a revision. I'm doing it because, as I said, we now want to use this knowledge. So just in case someone forgot it, then this would be a good revision. But I will go through this portion quickly. Okay. Then understanding distribution. That is the second part of our chapter, in which we will learn about various data distributions. We have so far talked only about one distribution, that is normal distribution. But there are multiple different kinds of distribution. If I show you a few, and that is just a few: uniform distribution, exponential, normal, binomial, geometric, hypergeometric. Then here this diagram, if I magnify it, then you can see some more also. That is okay, beta binomial, Bernoulli, gamma distribution, Poisson distribution, then Cauchy distribution, then many other distributions. Okay, so that is the distribution, means how your data points are spread. When you plot a graph of y versus x, at that time how your data points will be spread. So we will do a detailed discussion on that part, and that part is really interesting, and that is completely new. So we will go slowly and we will focus on everything. Okay, and then this part, basic inferential statistics, introduction to hypothesis testing and p-value. So this is also very important part and completely new part. So we will go very slowly, and we will try to do as many examples as possible, real life examples, so that you feel interested. And this is very important. So in short, first part revision, second part interesting and important, and third part also very important. Okay, so let us start first part, descriptive statistics. Now what is descriptive statistics? As the name itself indicates, you want to describe. Now earlier also we have done actually that when you use df dot describe after importing some data frame inside, then you will get a statistical summary of all numeric variables. And if you want to include the categorical as well as numerical variable, then you write this include equals all. Then it will give you statistical summary of numerical as well as categorical variable. And if you want only categorical variable numerical summary, then you can write include equals object. Okay, so this is the situation. Now here we want to write, we want to understand that descriptive statistic. Whatever things you get by that describe, but what are those concepts? That describe command gives some results, but what are those things? Now this is pure revision. We have already done in much detail, that you can see starting from here. That is maybe, yeah, mean, median, mode, arithmetic mean, and all that, variation, range, interquartile variance, standard deviation, shape, skewness, and kurtosis. Here also the same thing: mean, median, mode, and range, and interquartile. In fact, it is the same diagram also. Okay, so these are called summary measures. So let us try to understand, and we will go very quickly. First, what are measures of central tendency? Then one is arithmetic mean, another is median, and another is mode. So let us quickly understand by taking some example of a real data. A very simple example we want to take. Somewhere I had made one data frame. Okay, I can take this also, but today I just made one new simple data frame. I want to use that. Yeah, this one. Okay, so these are 10 observations: 1, 2, 3, 4, 5, and 10. And these are the values of those observations. And here, for just simplicity, I have written the values in descending order, but there is no need. They can be randomly distributed. So after 20, there might be some value, 18, fine, but after that 19 may also come. After 15, maybe 18 may also come, like that. But if you want to find median easily, then you have to arrange the observations in ascending or descending order first. Please remember that. So I have arranged them in descending order. Okay, so these same numbers 10 were given to me, maybe in some jumbled order, but I have arranged them in descending order. Now what is mean? Then the definition is very simple: sigma xi, where I is equal to 1 to 10 here, because there are 10 observations, divided by n, where n is equal to 10 because the number of observations, or that is the sum of all observations divided by number of observations. Now if I find the sum of all these numbers, that I get 96, and divided by number of observations are 10, so the mean is 9.6. Now there also we saw that there are two symbols used. This symbol x bar is used usually for population mean. Okay, so if it is population mean, then X bar is used. And I have talked about what is population and what is sample. Suppose you are a data scientist for a large retail firm like Walmart or maybe Amazon, and you are given a data set of 2 million customers. These kind of giant retailers, they have more than 2 million sometimes customers because their operations span over more than 100 countries. So now you are given a data set of 2 million customers and you are asked to verify some hypothesis. Maybe some hypothesis is that uh, on giving 5% of the additional discount on this X item, the number of sales would increase by 10%, true or false. So you have to check before the company announces the discount. It checks the how sound its hypothesis is, because if sale is not likely to increase or maybe it is likely to decrease, then there is no point in giving discount because that will cause loss unnecessarily. So you are given hypothesis that 5% additional discount will increase the sales and profit by 10%. Check it. Now, will you check that? For checking, when you make a data frame, will you use all 2 million observations? No. From 2 million observations, you will just randomly select a limited number of observations. So that 2 million, that is called population, and the randomly selected few observations, that is called sample. So somewhere I have earlier also, yeah, this is that diagram, right? So you can see that this is my suppose whole population of 2 million observations, while I have to take only some few records, and I have to take few records in such a way that they are truly representative of entire population. Okay, so suppose I take from 2 million 5,000 records, only 5,000. They are more than enough, because there also I told you that there is something called central limit theorem, which says that if under certain conditions, if certain assumptions are satisfied, then these 5,000 records, whatever results, statistical results you get for these 5,000 records, they are applicable to this entire population. Okay, we will discuss about the central limit theorem. So at that time you will see what is that. But so but condition is that under certain assumption means there are many assumptions, but one of the most important assumption is that your sample, this red is called sample, 5,000, while this 2 million observation, that is called population. Then the under certain condition means actually just around 1, 2, 3, 4, 5, 6, 7, 8, and so on up to that maybe 2 million. Okay, that are spread at different levels. So you have to take one observation from here, maybe one from here, maybe one from here, maybe one from at this point, maybe one from that point, maybe one from that point, and so on, right? So you are taking observations from different ways. You are not taking all the observations from only this area. Then that would be a kind of lopsided sample. That sample will not give results which are applicable to entire population. But if I take properly, the sampling techniques are also, there is a huge topic on sampling techniques, and if some proper sampling techniques are used, then whatever conclusion I get for my sample, same conclusion is made for my is true for my entire population. Now this much discussion I did because that X bar is actually used for the mean of the entire population, while for sample we use another symbol, and that another symbol is mu. Okay, so let us come back to our that 10 observations. Obviously there are only 10 observations, so clearly this is only sample. So better symbol would have been mu and not X bar. Okay, so mu, the sample mean is 9.6. Then median, if you want to find, median is just a middle observation. So that means 50% of the observation should be above it, higher than that, and 50% of the observation should be below it. Now that means if you arrange in descending order like that, then take 4 observations from this side and 4 from this side, then whatever remains in middle, that is your median. Now unfortunately in this case the number of observations are even, and therefore 2 numbers remain in middle, 8 and 7. So what is my median? 8 or 7? No, none of them. My median is the arithmetic mean or average of these two. So median is 8 plus 7 divided by 2, or the median is 7.5. And what is the mode? Then if I see the observation, then all observations are having only one occurrence, but this 4, that is here occurring once also and second time also. So the number which is occurring maximum number of times, or the number whose frequency is the maximum, highest frequency number, that number is called mode. Okay, so one thing you can see that median can be a data point which is outside the data set. So that you can see 7.5 you find anywhere in these 10 observations? No, but my median is 7.5, correct? Mean also can be a data point which is not part of my data set. So again 9.6 is not part of my data set, but mode is always the point which is part of my data set, because mode by definition is that number which occurs the most frequently. Okay, so that is the summary about this arithmetic mean and all that. So mean is the sum of all data points divided by number of points. Median is the value which separates higher half from the lower half of the data set. So I showed that higher half and lower half, and if there are 2 points, then take their average. The value that appears most frequently in the data set, that is the mode. However, in the mean, there are several different types of mean. One is called arithmetic mean, so that is the normal our mean. But apart from that, that what we call average. Okay, but there is trimmed mean, geometric mean, harmonic mean, weighted mean, among which the 2 we had already done here in 5th chapter. That is here, for example. that this is harmonic mean, this one, this red colored part, and this is this blue colored, that is the geometric mean. So how to decide that? That also we had seen that this is some number, say A, and this is another number, say B. So what we do is we represent them by one single line segment. So obviously A is greater than B, so that line segment has major part A and the smaller part is B. But we will do A plus B, and that entire thing we treat as a diameter, and we draw a semicircle. Okay, once that semicircle is drawn, then we join one the center of the semicircle. Center will be where? It will be A plus B by 2, because that will be the arithmetic mean, right? So arithmetic mean is the center of the semicircle. Then from where I can join it here this way, that is somewhere here. Okay, then and draw one chord here this way. Then this, from that chord, now from where this chord should be drawn, forget about this first this chord has to be drawn. From where the chord has to be drawn, as I said, A is greater than B, so that means A, its end point is here. Then you have to draw the chord, blue color chord, from the greater point. Okay, so this is my A. Now from A, the length of that chord, that is called geometric mean. That is its value. If you find, it will be under the root AB. Okay, under the root this number multiplied by this number. Okay, then wherever that chord intersects, which chord? The chord which is drawn from the arrow point or the tip of the larger number, the line segment which represents the larger number of the two. Wherever that chord intersects the semicircle, from which you join the from that point you join draw line segment that joins this center. Okay, so this is the line segment which is joining to this center. Fine, and this point is then called harmonic mean. Fine. So now this point is harmonic mean. How to find that? Because when I join that point to the center, it will become a radius. So to find the harmonic mean, I have to drop a perpendicular again from same point. Again from same point means from the tip of the larger number to the radius. And once that foot of the perpendicular is found, then from the point of intersection of that blue color chord, which represents geometric mean, I have to find the length up to the foot of this perpendicular, not the entire radius, but this much. That gives the harmonic mean, and that is 1 upon 2 divided by 1 upon A plus 1 upon B, its value is. Okay, and that is 2AB upon A plus B. If you simplify this, B plus A will go in the denominator and divided by AB, so that will go in the numerator. So it is 2AB upon A plus B. So that is the 2 multiplied by multiplication of two numbers divided by sum of two numbers. Now I have done all this discussion much earlier. That is why I am going through this discussion very, very quickly. But this is how you can find this harmonic mean and geometric mean. Similarly, this trimmed mean is there and this weighted mean is there. I can also show you this by some geometrical example, but I am not wasting time in that, because we are never going to find arithmetic mean or geometric mean or harmonic mean by drawing the semicircle and all that. These are all 9th standard or maybe school level methods. We will always find by programming, and our programming libraries are so powerful that they have the direct function for finding this. For example, we have already done in that chapter, this chapter, that if you want to find geometric mean and harmonic mean, then you will use SciPy library. Arithmetic mean can be always found by NumPy library, so you can easily find it. So these three, mean, median and mode, they are called measures of central tendency. So what is mode? Most frequent data point. Mode can exist as a data point, or mode can also be a point outside the data point. There may be more than one mode. Now that is also worth understanding, that suppose here instead of these 8, 7, suppose instead of that this number also would be 8. So in that case, how many mode will be there in this sample? Then there would be two modes. One mode is 4 and another mode is 8. So it is possible that given data set can have two modes, but mode is always a part of the data set, right? Mode is unaffected by extreme values. Now what is the meaning? What is the meaning of unaffected by extreme values? That we will see by median and other things. Okay, then median is a value which divides the ranked data point into half, 50% larger and 50% smaller. I showed you. So this is the median, 50% larger, 50% smaller. So then here 8 and 7 was there. That's why I took 8 plus 7 by 2, right? So let me make it back to original value. That would be better, right? Okay. Now then it may not exist as a data point in the set. Now that also we have done 7.5 is the median. So it is not part of data set. And it is influenced by position of item, but it is not influenced by their values. So if there is some extreme value here, say out of all these numbers are more or less closer. 2 to 20 is not called a very big difference. But suppose among them one number is directly say 2 lakh, or that is or say 2 million. So obviously the mean will change greatly, because rest of the numbers will be same. But this 96 minus 20, minus I am doing because this 20 will be removed, and plus 2 million. So then what it will become? 2 million and 96. Are you getting? Instead of this 20, if there would be 2 million, then 2 million and 96, and 2 million and 96 divided by 10. So that would be, what would be the mean? 0.2 million, or that would be 2 and another 5 zeros. So you can understand that mean will be greatly affected if there is some extreme values instead of these, if there would be a value like 2 million, so in that case mean will be greatly affected, right? But will median be affected? No, because median just depends upon 5. There should be 4 above the 4 higher than median and 4 lower than median. So that means still the median is 8 plus 7 by 2. And will the mode be affected? No. So mode and median, they are not much affected by extreme values. Mean is affected by extreme values. Okay. Now here it is written, this is actually wrong, that mean is most stable measure. No, it is not most stable measure. The very next line says it is affected by extreme value. Okay. And mean also may not be a part of my data set. So here my mean was 9.6 and that was not part of my data set. Okay. Now it is not stable. In fact, median is considered to be more stable than mean. Okay. Now similarly, later on we will see some this kind of thing and this kind of things. So this graph, middle graph, that is called a pure normal distribution, perfect normal distribution. Okay. And for that distribution, mean, median and mode, everything coincides at the same point. Okay. Now, but instead of that, you may get one this kind of distribution that is called left skewed distribution. For example, here this pink distribution, left skewed. Okay. So in that case, mode, mean and median, all three can be away from each other. So all three can be distinct points. And similarly, this is called right skewed distribution, or here this is called right skewed distribution. The graph is has a longer tail on the right side. Then also mode, median and mean, these are clearly the different distributions, different points. Okay. So only for normal distribution, mean, median and mode are same. This is one important property of normal distribution, so please remember that. Okay. Now the question is, there are three. Now this is something new, so please pay attention. This is not what we covered in earlier 5th chapter. Otherwise, whatever discussion I have done, if you found that it was very quick, but please refer to this chapter 5. We have done this in much detail. Okay. So actually, I could have directly skipped that and told you that refer chapter 5 that its lectures are there. But this is something new, so I will take that in the next lecture. Stopping here. Thank you.